Hello viewers, again it's your tutor, teacher Kariuki, and I'm here to take you through parametric differentiation. So this is under calculus 1, and I believe that those students who are in college and those who are in the university are going to familiarize with this concept called parametric differentiation. Therefore, feel free and be ready with your book, with your electronic calculator, and everything that you need so that we can do this together. So we have an example here. Given that x is equal to t cubic and y is equal to natural log of t squared minus 1, find change in y over change in x and the second derivative, which is d squared y over dx squared. So we have two different functions. We have the first function, which is a function of x with respect to t, and we have the second function, which is y with respect to t. So for us to get the first derivative in our solution, we are going to take our first function and we differentiate x with respect to t. So dx over dt is equal to, this we are going to differentiate it normally, and we are going to have 3t squared. So when we have that 3t squared, the next thing we are going to do, we will take the second function, which is y is equal to natural log of t squared minus 1. And for us to differentiate this particular function, this is under the derivatives of logarithmic functions. I'm going to do a video on how you go about the derivatives of logarithmic function. So this is going to be dy over dt is equal to, so when you have the natural logarithm of a function, it becomes 1 over the function, that is t squared minus 1, multiplied by the derivative d over dx of the function, that is t squared minus 1. Therefore, dy over dt is going to be equivalent to 1 over t squared minus 1 multiplied by 2t. Multiplied by 2t. And that will definitely give us 2t over t squared minus 1. So that is going to be our dy over dt is equal to 2t over t squared minus 1. So for us now to find or to determine the dy over dx, we need to understand that dy over dx is equal to, we already have dy over dt, so it will be equal to dy over dt multiplied by dt over dx. dt over dx. So you have dt over dx. So we already have our dy over dt, that is equal to dy over dt is equal to 2t over t squared minus 1, and we already have dt over dx. Remember that our dx over dt is equal to 3t squared. Therefore, our dt over dx is equal to the reciprocal of 3t squared, which is 1 over 3t squared. So, having the two, we can be able to determine the dy over dx. So, dy over dx will be equal to dy over dt is 2t over t squared minus 1, 2t over t squared minus 1 multiplied by our dt over dx is equal to 1 over 3t squared. So it will be multiplied by 1 over 3t squared. 1 over 3t squared. And when we multiply, you are going to get your dy over dx as 2t multiplied by 1 will be equivalent to 2t over 3t squared multiplied by t squared minus 1. That is like opening a bracket. We are going to have 3t to power 4 minus 3t squared. And by doing that, we have already determined our dy over dx. So, I hope you have understood how we have gone about this question. Here we had dx over dt. For us to get dt over dx, it is the reciprocal. That is dt over dx is 1 over 3t squared. And by doing that, you have already solved your question. So we already have a tick. Halfway of the question is correct, correctly done. So you can say you have your 2 marks there. So I want us now to proceed in solving the next question. And the next question is d squared y over dx squared, or what we call the second derivative. The second derivative. So how do we go about solving the second derivative? The second derivative will be solved by the following method. So d squared y over dx squared is equal to, we will first find the derivative of the first derivative, that is d over dx of 2t over 3t to power 4 minus 3t squared. Then we multiply by dt. We multiply by dt over dx. We multiply by dt over dx. That simply says that d squared y over dx squared is equal to d over dx of dy over dx multiplied by dt over dx. That is how we approach that question. And for us to continue this question, we are going to proceed it on this particular part. We are going to proceed it at this particular part. Squared y over dx squared is equal to d over dx of 2t over 3t to power 4 minus 3t squared, then multiply by dt over dx was 1 over 3t squared. So for us to determine the differentiation of this one, we are going to use what we call the quotient rule. So here, we will use the quotient rule. The quotient rule. And the quotient rule states that when we are differentiating this, using the quotient rule, that simply means that it is going to be equal to, we will hold the denominator. We will hold our denominator as constant 3t to power 4 minus 3t squared. When we hold it, then we will differentiate the numerator. That is d over dx of 2t minus, we hold the numerator as a constant and we differentiate d over dx of 3t to power 4 minus 3t squared over the denominator squared. That is over 3t to power 4 minus 3t squared. That is how we go about it. So when we do this, we are going to have 3t to power 4 minus 3t squared multiplied by 2, then minus 2t. When we differentiate this, we are going to get 12t to power 3 minus 6t over 3t to power 4 minus 3t squared. Then that is squared. And by doing that, we are going to get, when you multiply this one, you are going to get 6t to power 4 minus 6t squared. When we open this bracket, we are going to get minus 2 times 12. That will give us 24t cubic. So it will be minus 24t cubed. Then this one, it will be minus 12t squared. So it will be plus 12t squared over 3t to power 4 minus 3t squared. When we simplify that, we are going to get 6t to power 4 6t to power 4 minus 6t plus 6t squared minus 24t cubed over 3t to power 4 minus 3t squared. So by reaching there, we have already found the d over dx of 2t. So we have already determined the d over dx of this one. It is equivalent to this one. Therefore, d squared y over dx squared will be equivalent to, when we multiply with 1 over 3t squared, it's going to be 6t to power 4 minus 24t cubed plus 6t squared over 3t to power 4 minus 3t squared multiplied by 3t squared. So that simply implies that d squared y over dx squared is equal to, here we can simplify, we can take out 3t squared and we can be left with, into brackets, let's do it over here, it's going to be 2t squared minus 6t plus 2 over 3t squared into brackets 3t to power 4 minus 3t squared. This one will cancel with that, and we are going to be left behind with d squared y over dx squared is equal to 2t squared minus 6t plus 2 over 3t to power 4 minus 3t squared. And that is our second derivative. So that is how we approach questions on parametric differentiation. We are going to do more examples. So I believe that those students who are taking mathematics and engineering courses, that is in the college and in the university, this is in calculus 1, you are not going to have challenges on this. Therefore, in our next lesson, I want us to discuss on how we find the derivatives of trigonometrical identities. Thank you so much for your attention. Also, I would like to uh, advise you to ensure you click the subscribe button and turn on the notification bell so that each and every time I upload new content, you are always updated on what is going on. Thank you so much. Be blessed.